In this section, we'll be looking at sine, cosine, and tangent using what are called the circular function definitions. When an angle is drawn in standard position, the sine, cosine, and tangent ratios can be defined in terms of directed horizontal and vertical distances and the hypotenuse of the reference triangle. By the way, the hypotenuse is always a positive number. Since we consider angles ranging from 0 to 360, the sine, cosine, and tangent can be referred to as circular functions. Now we're going to consider angles with terminal sides in each of the four quadrants. Their reference triangles are always going to be drawn with the horizontal side on the x-axis. Using SOHCAHTOA and the reference angle can be used to find the sine, cosine, and tangent ratios for each angle. In quadrant 1, we can draw the reference angle, and the reference triangle, and the reference angle is inside of that triangle, and the reference angle is actually the same as the angle theta, because it's between 0 and 90. Now, if you consider that ordered pair a comma b, remember how do you get from the origin to a comma b, and that is you travel over a units and up b units. C we're going to use as the hypotenuse. So in quadrant 1, theta equals the opposite over the hypotenuse, and the side opposite theta is b, and the hypotenuse is c. Cosine theta is adjacent over hypotenuse. The leg of the triangle adjacent to theta is a, and the hypotenuse is c. The tangent of theta is the opposite over the adjacent. The opposite is b, and the adjacent is a. Now let's look at an angle in quadrant 2. Theta is the angle as rotated from the positive x-axis to the terminal side of the angle. We can draw a reference triangle with the horizontal side on the x-axis, vertical side parallel to the y-axis, and the terminal side is the hypotenuse. The reference angle, or theta ref, is on the inside of the triangle, and you can see there that it's supplementary to the angle theta. Again, to get from the origin to point a comma b, we'll go over to the left a, up b to get there, and notice that a is negative when we're in the second quadrant. Again, we can find the trig ratios. Using the reference angle, sine of theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is over adjacent. Now let's move into quadrant 3. Theta is the angle that is larger than 180 degrees, starts on the positive x-axis and rotates to the terminal side in the third quadrant. A reference triangle can be drawn with sides A, B, and C. Notice that to get from the origin to the point a comma b, we go over A and down B. In that case, both A and B are negative. The reference angle, or theta ref, is the angle that's on the inside of the triangle. And notice that that is an angle that is the amount of the angle that's larger than 180. So it would be the angle measure minus 180. Sine of theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Now let's look in the third quadrant, where theta is the angle that extends from or rotates from the initial side on the positive x-axis to the terminal side in the fourth quadrant. We can draw our reference triangle with the horizontal side on the x-axis and the vertical side parallel to the y-axis. And notice that to get from the origin to point a comma b, we have to go over a and down b. Notice that b is negative in the fourth quadrant. Reference angle goes inside of the triangle, and notice that theta and the reference angle add up to 360 degrees. So sine of theta is opposite over hypotenuse. Cosine theta is
adjacent over hypotenuse.
Theta is opposite over adjacent. What you'll notice is that all of these sine, cosine, and tangent values are the same no matter which quadrant where our terminal side is located in. So let's generalize this. For an angle drawn in standard position with endpoints 0, 0, or the origin, and a comma b, the sine of theta is b over c, or the vertical side over the hypotenuse. Cosine of theta is a over c, or the horizontal side over the hypotenuse, and tangent of theta is b over a, or the vertical side over the horizontal side. Quick note about that, that's essentially slope. It's a rise over run. And where does c come from? Well, c is found using the Pythagorean Theorem and is the square root of a squared plus b squared. In example 1, we're going to draw an angle in standard position with a terminal side passing through the given point, and then we're going to find the values of all three trig ratios. The point 5, -12 is in quadrant 4, and theta is the angle that rotates from the initial side on the positive x-axis to the terminal side in quadrant 4. The reference angle is the angle that's located inside what will be the reference triangle, which is drawn with the horizontal side on the x-axis and the vertical side parallel to the y-axis. Let's label the sides. It's important that you begin to label sides of a triangle with directed lengths. That is, since -12 is a side of the triangle that is hanging down from the x-axis, it has a vertical distance that will be considered negative because it's directed downward. Now we can use the Pythagorean Theorem, or just recognize the 5, 12, 13 triple to find the hypotenuse. Find sine theta, cosine theta, and tangent theta using SOHCAHTOA. Sine of theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tangent theta equals opposite over adjacent. Now let's take a look at B, where the ordered pair is 1, 2, which would be located in the first quadrant. Once we plot the point, we can draw the reference triangle, then label the sides. The next step will be to find the value of the hypotenuse, which turns out to be the square root of 5. Now we can use SOHCAHTOA to find the values of sine theta, cosine theta, and tangent theta. Sine theta is opposite over hypotenuse, and this will need to be rationalized. So sine of theta is 2 root 5 over 5. Cosine of theta is adjacent over hypotenuse, and this will need to be rationalized. So cosine theta is root 5 over 5. Tangent theta is opposite over adjacent, and this can be simplified to a value of 2. Now let's look at C. The point -8, 15 is in quadrant 2, and a reference triangle can be drawn. Recall that the angle theta goes from the positive x-axis to the terminal side, and the reference angle is contained on the inside of the triangle. The sides can be written on the reference triangle, and since 8, 15, 17 is a triple, we know that the hypotenuse is 17. Now we can use SOHCAHTOA to find the values of sine theta, cosine theta, and tangent theta. Sine of theta is opposite over hypotenuse, and cosine theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. Now let's look at D. The point 3, 0 is on an axis, which means that it's not contained within one of the four quadrants. It's in between quadrants. So we're going to need to use the unit circle definitions, or rather the circular definitions. Sine of theta equals b over c, sine of theta equals a over c, and tangent theta equals b over a. The a and the b values are the x and the y coordinates of the point on the terminal side. We can use them to find the value of c using the Pythagorean Theorem. So the value of c is actually the same as the value of a. Sine of theta would be b over c, which is 0 over 3, which can be simplified to 0. Cosine of theta is a over c, which is 3 over 3, be simplified to 1. Tangent of theta is b over a, which is 0 over 3, which can be simplified to 0. Now try the example below on your own. Here are the answers to the try this. Make sure that you are doing two things. We need to rationalize the denominators for the sine and for the cosine, and for tangent we'll need to simplify a negative over a negative to a positive ratio. Alright, in example 3 we're going to be given the measure of an actual angle, and then we're going to find the values of all three of its trig ratios if possible. In 2a, a 90-degree angle has a terminal side that's on an axis, not in a quadrant. So we'll need to write coordinates of the endpoint of the terminal side. We don't actually know the endpoint of the terminal side, but we do know that the x-coordinate is 0. The y-coordinate is some positive number, and we're just not sure what it is, so I'm just going to pick an easy positive number, 1, to represent the y-coordinate of the terminal side. The value of c can be found by taking the square root of 0 squared plus 1 squared to get c equal to 1. You'll notice that the c and the b values are the same number. That's going to happen when we have an angle that's in between quadrants. Now sine of theta is opposite over hypotenuse. We don't really have a triangle here, but the opposite side, if you remember, was always vertical. So that means we're going to take the vertical coordinate, which is 1, and divide it by the hypotenuse, which is 1. So that means the sine of theta is 1. The cosine of theta is the adjacent over the hypotenuse. And we don't have a triangle, but if you'll remember, the adjacent side was always horizontal. So we're going to take the horizontal coordinate, or 0, and write it over the hypotenuse, which is 1, and 0 over 1 equals 0. The tangent of theta is opposite over adjacent, and opposite is vertical, and adjacent is horizontal. 1 over 0 is undefined. It will be important for you to know when an expression is undefined. Alright, let's try b, which is 210. 210 is beyond 180, and in fact is 30 degrees beyond 180. We know the sides of a 30, 60, 90 triangle. Across from the 30 is 1. Across from the 60 is the square root of 3. The hypotenuse is 2. Next, we need to make sure that the sides have appropriate signs assigned to them. Since this is in Quadrant 3, both the x and the y coordinates, or the opposite and the adjacent sides, are negative. Now we can use SOHCAHTOA. Sine theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent theta is opposite over adjacent, which needs to be rationalized, and the negative signs need to be canceled. So positive square root of 3 over 3. In C, we have a 225 degree angle, which is 45 degrees beyond 180. We know the side lengths for a 45-45 right triangle, and can assign A and B as negative since the terminal side is in the third quadrant and both coordinates are negative in the third quadrant. Sine of theta, or rather 225 degrees, opposite over hypotenuse, which simplifies to negative square root of 2 over 2. Cosine of 225 degrees is adjacent over hypotenuse, which simplifies to negative square root of 2 over 2. Tangent of 225 degrees is opposite over adjacent, which simplifies to 1. In D we have a 180 degree angle whose terminal side falls on the negative x-axis. We know a couple things about the coordinates of a point on the terminal side. First off, the x-coordinate is negative. We don't know what value it is, but we can assign it negative 1, just to make an easy number. We also know that the vertical coordinate is 0. Now we can find the value of c using the Pythagorean Theorem. C is the square root of negative 1 squared plus 0 squared, which equals 1. 180 is opposite over hypotenuse. Our opposite side is the vertical side, so its value is 0, and that simplifies to 0. Cosine of 180 is adjacent over hypotenuse, and our adjacent side is always horizontal, so it is negative 1. And negative 1 over 1 simplifies to negative 1. Tangent of 180 degrees is opposite over adjacent, so that would be vertical over horizontal, and that simplifies to 0. All right, try the example below on your own. All right, here are the solutions for the try this. What you'll notice is that we can use SOHCAHTOA anytime we can draw a triangle. The angles for which we can't draw a triangle are those that have a terminal side on the x-axis or the y-axis. These are known as quadrantal angles. Instead, we're going to use the circular definitions for their trigonometric functions. Hint, for every quadrantal angle, either A or B will be 0. The value of the other coordinate does not matter, except that we will need to make sure that it is correctly positive or negative. That's it for today's lesson.